So, good morning, dear students. Today we will discuss polymorphism. Polymorphism is one of the important feature of the object-oriented programming system, right? As we have discussed, there are three important features which being exhibited by any programming language. We say it is an object-oriented programming system, wherein we said encapsulation, inheritance, and polymorphism. So we have of data and functions together into a single entity called class. With the help of class concept, we are able to implement that encapsulation concept. We have seen how to write the classes and how to implement the classes with the help of its instances, and we have further seen that what are the different ingredients that are associated with particular classes like constructors, destructors, and all. Fine. And how you are going to implement them, how you are going to define their properties and implement all such kind of things that we have seen before. And next thing, like inheritance. Coming to inheritance, we said inheritance is the second important property of object-oriented programming. So we said that inheritance is basically being used to implement the reusability concept, and it extends the reusability concept with various kinds like single level, multi-level, multiple, hierarchical, hybrid, and all. We have discussed all these kind of inheritances, and then now if there are constructors available in the classes, how does the derived classes should respond to the same, and how does the memory allocation and deallocation for the derived class objects are going to happen, and what are the issues also with that particular inheritance. We have seen typical example wherein probably by taking a typical example, we have seen that when the duplication of certain classes being happened, basically the base class, right? How to avoid that virtual base class and virtual inheritance. Fine. And we have seen in inheritance a couple of concepts like how to inherit the constructors. If you have constructors, how the destructors when you have will be taken care, and in what way when the derived class object destructor is being called, the base class also automatically being called. We said that base class destructor has to be a virtual destructor. Only then the base class destructor will be implicitly called whenever the derived class object scope is out, right? Similarly, for constructors, when you have constructor in the derived class, you must have to have a constructor in the base class, and which is required to be inherited at the derived class constructor in a very similar fashion how the base class is derived at the derived class thing. So all this we have discussed, right? And then coming to polymorphism. Polymorphism is third important feature of the object-oriented programming system. So what do you mean by polymorphism? Basically, availability of a certain functionality, certain property, certain operation, right? Certain method in different forms, right? In different forms. Like for example, you have carbon polymer, diamond polymer, right? Formula will be same, but generally the availability, the of that particular one, in representation, going to be varied from one particular replica to another kind, right? So here, now bringing that kind of real-time property into the programming languages is what exactly the polymorphism here I'm talking about, right? So polymorphism I can classify into two kind, okay? I can say one is static polymorphism, another one is dynamic polymorphism. Okay, static, or I can say it is compile time. Okay, Dynamic, or I can say it is runtime. So why do I say it is static? Because the binding of functions, right, is going to be done during the compile time. Here, the binding of functions is going to be done during the runtime. That is a reason why we are saying it is static and dynamic. Okay. Now coming to static polymorphism. Here, static polymorphism can be achieved in C++ with the help of function overloading. And then operator overloading. Okay. Anyway, we'll see this thing in detail, of course, in the coming chapters. What is function overloading? What is operator overloading? And now coming to dynamic runtime polymorphism, we can implement it with the help of virtual functions, right? Okay. So of course, this one also will deal it in detail in coming classes. Fine. Now looking at function overloading first, starting with function overloading. Yeah, what do you mean by function overloading? Having more than one function with the same name. Look at the definition of function overloading, which I have here stated. By changing the parameters in number, order, and type. Okay, so it means I can have multiple functions with the same name. For example, I have a compute function, right? Okay, the compute function I can have multiple times defined with different operations. Okay, but how does the differentiation took place in the computer is with the parameters, right? So by changing the parameters in number to certain compute function, you can give number of parameters as 1, and to some you can give 2, to some you can give 3. Similarly, you can change the type. For example, if you have a function with one argument wherein you have given integer, now with the same name, you can have this singular argument but with a different type, float. Right. So by changing the type also you can differentiate, right? And by changing the order, in the sense that if you have, so for example, you have a compute function with two parameters, int comma float, I can have another compute function with float comma int, right? By changing the order. In first instance, let us say I have int and float in sequence. Then in the next, kind, I can have float first and then int. So that way I can probably have. So by changing the order or number or type, I can have any number of functions to be written, and then able to implement different kind of functionality in the other way around, different kind of operations, right? Okay, we'll try to demonstrate this with the help of an example. I will see if I you don't using namespace std, then I have to access it like this: std scope resolution operator, then cout HX. Right, this way also fine. Otherwise, I can have it using namespace std. If I write this, then I don't need to have this, right? Directly go with this. This. So fine, you got the output. Hello world. Now we'll try to write a program here to implement function overloading. I'm taking a class here. Class name is overload. Font size is visible, right? Or you want me to increase?
Visible, sir.
Good. So class overload. I'm taking here one function. Checking variables A, B, and let's say C. Okay. Under public mode, I'm having one constructor here. Overload. Okay. I can define the code here itself, or else I can define outside. However I want. Let us define the code here itself. A equal to 0, B equal to 0, C equal to 0. Okay. Then I wanted to have a function like, let us say, compute. Okay, void compute. This function is having no arguments. Okay, without arguments. And another function I have with the same name, compute, but it is having one argument. Okay, and I'm having another function with the same name with two arguments. Okay. Fine. So now let us try to define the code of these all three different functions. I wanted to perform different kind of operations in each of these compute of course, right? So when I write the code outside, I just say a return type, then class name, then I say scope resolution operator, then I say function. Okay. Now in this function, I wanted to have let us give some values. Otherwise, instead of 0, I say this, let's say 20, and let us say 10. Okay, default values C0. So I just wanted to go with the default values in the function without arguments, wherein I want to perform, let us say, addition operation A plus B. Okay. And now let us print the output of the same. Sum equal to C. Okay. Now I'm going to define another function here. With the same name. But now it is having one argument. Let us take this argument as x. This x I wanted to take it in, let us say a. So a value will be changed now when this function is called. And here I wanted to, let us say, perform subtraction. And let us say the result I am printing is the difference. Now, let us take another function to be defined here. With two arguments, can have int x comma int y. Now I am initializing even b as well with the parameter that I am receiving from the function call. Let's say I want to perform here multiplication. So I will say here the product of those two variables is available in C to be printed here, right? Now, now here I'm creating an object of overload. Let us say an object is created here. Now I wanted to call these functions compute without arguments, b dot compute with one argument, and again compute with two arguments. Let us say. Okay. So now let's try to execute this program. Before executing, I just wanted to explain you what is happening here. Class overload. Okay, this is a class here. Overload is a class here. Fine. And in this, we have three variables. We see are its data members, and we have overload. This is a constructor, called constructor we have, right? And then these three are functions. Okay, so here you can see this function is having no argument, this function is having one argument, this having two arguments, but all three of them are with the same name. Generally in C you may have seen when you are writing the function name to be defined multiple times. No. Why? Because there is no function overloading concept, right? In C++ we have that. You can see same name, compute. You can see there is no spelling mistake, there is no case sensitive. You can see with all, the perspective, you can see it is same compute, right? Name doesn't change here in all these three functions, right? Having the same function, right, with the same name, having the same function name with multiple definitions to perform different operation is what said to be the polymorphism. Okay, so that is what we are trying to here implement here. You can see. So in this compute, which is having no argument, is this one where I am performing addition operation, and this is performing subtraction operation, and this one is performing what? Multiplication operation. This one with two arguments. This is defined below, multiplication operation. So operations are different. See, when I am calling, you can see here I am calling Here I am calling these three functions compute, compute, compute. So when I am calling compute, 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 here I can see the addition operation will be carried out, here subtraction, here the multiplication. So same function name performing differently is what said to be the polymorphism. Now why I am saying it is compile time polymorphism, you know function prototype concept, right? Function prototype consists of what? The data type, function name, arguments in number, order, and type. Okay, this all together will be represented as a function. This is going to be notified by the compiler. Fine. Compiler has the function prototype specification. Fine. Now let us try to understand when it executes, right? What happens? Then obviously we automatically understand polymorphism and as well the why it is compiled, right? So now let us look at here. The first statement in the main function which we have is an object to be created, right? We are creating an object, right? OP. So when an object is created, what happens? What all the memory required for its data, the memory will be created for it, right? Here, overload consists of about three members, A, B, C. So for A, for B, for C, 2 bytes each memory will be allocated. Now, in that overload, we have a constructor as well. You have seen default constructor, we have defined that, right? So when you're creating an instance, the constructor will be automatically called, right? When constructor is automatically called, in constructor I have given some code to define, to initialize A, B values, right? A, B, C values. A value is being initialized with 20, you can see there, and B is initialized with 10, and C is initialized with 0. So this is done till here. Now next thing is ob.compute, right? Compute function is when called here. You can see there are three different functions, right? So, but then compiler has the function prototype concept, so it can be able to differentiate all these three functions, right? With the parameters, right? With the parameter, because the parameters are being deferred here. In one we have no parameter. In one, what it does, it checks the number of parameters are the actual values, actual parameters that you are passing while calling the same. Here you are passing no parameters. Yes or no? You are passing no values, right? There are no actual values. So automatically it identifies that it is with no parameters. So it I bind it with the function with the no parameter one. Okay. So binding of function is done during the compile time itself, because the compiler knows, because compiler has the function prototype concept, so based on which it could be able to differentiate, though the same name is called here differently on different times, right? It could know that which one has to be binded to which particular function, right? So this is going to be binded with no parameters, and this is going to be binded with one parameter, and this is going to be binded with two parameters. Fine. So compiler itself is taking care of binding it. So the binding of the functions to that object, which one has to be called out of these three, right? We have two compute, right? Sorry, three computes. Compute with 0. Compute with one parameter, compute with two parameters. So here this is going to be binded with this, and this is going to be binded with this, and this is going to be binded with this, right? So this binding is done when it is done during the compile time. There is a reason why we say it is a static or compile time polymorphism, right? Why we say it is a polymorphism? Because here it is performing addition, here it is performing subtraction, here it is performing multiplication. See, you can see the same name. Availability of the same function in different forms is what's said to be the polymorphism. This is polymorphism. This one. and since they are being binded during the compile time, it is a static polymorphism. I hope this is clear to you. Right. Now, what happens right when it is executed? Compute function is called here. When compute function is called in compute, you can see there is a addition operation to be carried out, right? So it is directly taking the values of a and b. Initially, a and b is carrying 20 and 10. So when it is performing addition, what do you get here in C? 30. So the first result that you get here is obviously what? Sum equal to 30. The next compute, when you are calling, what happens by passing 50 here? This 50 is being initialized to a there. You can see it is passed to parameter x, and thereby from x it is initialized to a. So a value gets changed to 50 when you are calling this particular function. Then, and what is that it is going to carry out? It is going to carry out the subtraction of a and b. So what happens when it is carrying out subtraction? 50 minus 10 is going to be 40. So C value is going to be 40 here. So the result which is going to be here printed is going to be what? Difference equal to 40, right? And then the next time when you are calling the compute function, you're passing two parameters. So which is going to be called? This one is going to be called. Then what happens? 50 is going to be taken into x, and via x it goes to a. So a value will be changed to what? 50, and 2 value is going to y. So y it is being transferred to b. So it is going to be 2 here in b. Then you're performing multiplication of a, and 50 into 2 is going to be 100 here. Yes or no? Then the same is going to be printed. So what is the output you are going to get? Product equal to 100. Yes. So you can see, though you are calling the same function, at different times it is performing different operations. Here's addition, here's subtraction, here multiplication, right? Why? We have defined the same function with error. Got it? But you have a provision to write more number of functions with the same name by changing the order as well, by changing the type as well, by changing the type in a sense. If you have, right, changing the order means if I have same compute function with, let us say, int float, I can have another function with float command, which you can have any number of time to define the same function, right? Compiler could be able to distinguish all that, right? Since it has the complete function. I hope this is clear. Now we'll try to execute and see. Okay. Let's execute and see. OB. Here I said capital OB, and here I said small. Let me change this. The object which I've created with capital O, right? Since C++ is also case sensitive, we will have to ensure that the lowercase uppercase to be given properly. Okay. Now we can see the output here: sum equal to 30, difference equal to 40, product equal to 100. Is it clear? I hope this is clear to all of you, right? So function overloading concept, I hope is clear to all of you. Any doubt here? Add it to my project so that it will be available here in online GDB. Is any doubt here? Yeah, the next concept that we wanted to discuss is the operator overloading. Probably definitely takes some time. It's already 10:50 now. Right? We'll better start it in the next class. Okay.